Rarer. So remember all of you, when the light is entering from rarer medium to denser medium, so the angle of refraction is less than angle of incident or more than angle of incident? Is less than or more than? Nobody is saying. So in this case, the angle of incident, understand, greater than angle of refraction means angle of incident is always more than the angle of refraction. Do you understand? It is decreasing here. Is it yes or no? Yes or no, Ra? Nobody is answering.
Yes, sir.
So that is what you should remember. So when the ray of light is entering from rarer to denser, the angle of refraction is less than the angle of incident. All of you should remember this. Or else angle of refraction is less than angle of incident. Or else angle of incident is greater than angle of refraction. Anything you can write it. All of you should write. You have to draw this diagram and you should write the statement also. If it is completed, you tell me please. Is it completed? Try to wake up in time and you have to learn well. You have to work hard. That is what I am saying. We have to shine in future. This is not the end for our life. Corona is not. Try to wake up in time and you have to attend everything. You have to learn everything. Ask me the doubts. Simply wake up in late and joining late is not good. Is it completed? Tell me. Over?
It's a complete.
Yes, sir.
Yeah. So now, remember, few times they may ask you to understand it. Draw the, like in the sense of rarer to denser or denser to right. So you have to write this point also when they will ask you that. Simply if you draw the ray diagram, it is not worth it. Depend upon the marks you should do it. Write it example. Understand? Right. When a ray of light, example, for this you should write example. When a ray of light goes from air into glass, when a ray of light goes from air into glass, it bends towards to the normal. It bends towards to the normal. Do you understand, Ra? Yes or no? Yes. So also we can use, in place of suppose, also we can use water and glass. Also we can use air and water. Everywhere it will be happen same thing. Do you understand? Okay.
Yes, sir.
That is what now. Case 2. All of you keep adding. Case 2. Case 2. Case 2. Case 2. What is case 2? Refraction of light. All of you keep adding. Refraction of light. Refraction of light when it goes from a denser medium to a rarer medium. Denser medium to a rarer medium. Refraction of light when it goes from a denser medium to a rarer medium. Do you understand? Yes or no?
Yes, sir.
Yeah. So we start now the same way like exactly. But now here, first we should take denser medium or rarer medium. We have to take denser medium. So let us draw the rectangular glass slab now. So this is what my rectangular glass slab. So again, what is the name of the rectangular glass slab? P, Q, R. Yes. And one more thing I'm saying you, rectangular glass slab if you'll observe. What is the property of rectangle? Anybody? Parallel sides are? Parallel sides are equal. Correct or not? So also we can call this as, understand, parallel sided glass slab. All of you should remember. Parallel sided glass slab. Also we can known as what? rectangular glass slab. Don't get confused. In exam, they may ask you parallel sided glass slab means are what you have not taught, sir. Like that, you should not say. Both are called as same thing. A parallel sided glass slab or rectangular glass block or glass slab. All are same. So now, this is what my understanding. Rectangular glass slab, which we used to call as what? Denser medium or rarer medium, which is glass, is known as
Intermediate.
and
Denser medium.
into the air. So air is called as what? Rarer medium. Is it yes or no? So here the incident ray, your choice. Incident ray is your choice. Either you can insert like this, understanding means it is going like this and it is bending, or else it is going like this and bending. So your choice. So but I am drawing downwards so that only I have drawn the glass slab up. If you insert the incident ray like this, you can draw the glass slab down. If you want, that is also I will draw. So now let us insert the incident ray. Again, what is the incident ray? Again, what is the incident ray? What is the incident ray, Ra? AO, understanding? So incident ray is AO. This is what the AO, and this is the actual path of light. This is the actual path of light. Understand? So let us imagine this is the incident ray, which is A and O. O means what? Where the point of incident, where the light is inserted. Now, if I draw the here normal, so let us imagine the normal. What is the normal, Ra? All of you, what is the normal? A perpendicular line. Is it yes or no? So if I draw a perpendicular line, N dash, understand? N, O, N dash. That is what we should call as perpendicular line. So N, O, N dash. So as we know that this is what the incident ray. Now, if it is same medium, it needs to travel in this particular path. This is the original path. So what is the angle of incident here? Anybody? What is the angle of incident here? Where it is located? Angle of incident. This is called as angle of incident. Is it yes or no? Is it yes or no?
Yes.
Now if it is same medium, then it will go this path. But it is traveling from denser to rarer. So that what will happen? What we have studied? If it is traveling from denser,
Move away, sir. Bend away from the normal.
Move away.
Bend away from the normal.
bends away from the normal, so that understand refracted angle will increases or decreases. If you really understand, you tell me. Refracted
Increases, sir.
angle
Increases.
Increases, sir. Increases.
it will increases so that it will become like this. So this is the refracted ray. And what is this ray called as? OB. Understanding? OB is the refracted ray. Refracted ray. All of you should remember. This is called as refracted ray. And what is the refracted angle? Is it increases or decreases? Actually, it needs to this, but it is increasing. You can see it is increasing. So this is called as refracted angle. So in this case, what will happen? Incident angle is less than, understand? Incident angle is less than a refracted angle, or refracted angle is greater than incident angle. Is it yes or no? All of you?
Yes, sir.
Is it yes or no?
Yes, sir.
What you should remember.
Yes, sir.
You should write. Draw this diagram perfectly. Why I am drawing this much perfectly? Do you understanding? Because of by using 3 markers and colors, because you are not supposed to get confused, and perfectly it should be. That is what. You are also in our classwork, you should use different pens, but in exam, single pen, everything should be. And always remember this understanding. Solid lines always you should show thicker, and this dotted lines you should show very, very light. Do you understand? While your drawing will make 2 shades. Is it yes or no? Like that. This glass slab, understanding, and this normal and original path, everything should show very light. Light means not invisible. It should be, but compared to this incident ray and refracted ray, they must show less lighter. Do you understand?
Yes.
That is a perfect way of drawing diagram. So this is what we should call when the light ray is entering from rarer to denser and denser to rarer. If you have any doubt, you please kindly ask me. Is it okay, Ra? All of you? Jesse? Again, Pranita having network problem, I think. Completed, Arvind? Nitinath?
Yes, sir. Completed.
So,
Yes,
Yes, sir.
you can write example. When a beam of light traveling in, when a beam of light traveling in, traveling, or you can write, okay. When a beam of light goes from glass into air, when a beam of light goes, when a beam of light goes glass into air, when a beam of light goes from glass into air, comma, it bends away from the normal. It bends away from the normal. Do you understand, all of you? Yes or no? No.
Yes, sir.
It bends.
Yes, sir.
Yes, sir.
Now you see, few times this ray diagram they will give you differently. By that time, you please kindly don't get confused because so many will get confused. Both the two diagrams now I will draw reverse. Shall we accept? Shall we draw? Because few times in exam you people may get confused. Now let us take the first case. Normally I will draw. You observe carefully. This is my glass slab. Understand? And here also this is my glass slab. Now first let us take from rarer medium to denser medium. Is it yes or no? Rarer to
Yes, sir.
denser. Now you see.
Yes, sir.
Denser, we have inserted the incident ray like this and it will bend towards the normal like this. Now, let us go reverse direction. I am inserting the incident ray like this. This is my incident ray. So let us take AO is my incident ray. So now, here if we draw the normal, here if we draw the normal, here if we draw the normal, then this is called as incident angle. Is it yes or no, all of you? Is it yes or no? Yes or no?
Yes, sir.
Actually, it needs to travel
Yes, sir.
in this path. It actually needs to travel in this path. But due to increase in density, what will happen, Ra? It will move towards to the normal. Do you understand? It will move towards to the normal. And this is only called as OB, the refracted ray. Do you understand, all of you? When we are drawing from
Yes.
bottom to up, just it is reverse of it. Is it yes or no? Then this will become the angle of refraction and this will become the angle of incident. I hope you understand. Yes or no?
Yes, sir.
Yes, sir.
The same way now you see. When the light ray, nothing will change. Here also angle of incident is more than angle of refraction. Now, here you see, the incident ray is inserting from denser to rarer. Anybody is having any doubt, you can ask me. Pranav, now see, before I have inserted like this and it is going like this. Now, the light ray will goes from, like this you imagine, water into air, water into air. So this is the actual path of the light. Is it yes or no, Ra? This is the actual path of light. Understand? So now, if we draw the normal here, this is what the normal, n and n dash. Here also, n and n dash. Now what will happen, you tell me? This is what the actual path. But due to entering from
Move away from the normal.
water and this is, so this is the actual path.
Move away from the normal.
Away from the normal. Is it yes or no? So this is AO and this is OB. So here it is, I mean, have you noticed it? It is bending away from the normal. Is it yes or no? Always you should remember
Yes, sir.
that point. So this is the angle of incident. This is the angle of incident and this is the angle of refraction. All of you should understand or not? Yes or no? So that is what, when you are drawing from bottom to up or up to bottom, the process is same. Always your mind should say it is bends towards to the normal and away from the normal. Sir, which one? This because it is coming opposite, left side, right side, so that you may get confused. So that is why I have drawn all the 4 diagrams so that you people should not get confused. Do you understand, Ra?
Yes, sir.
Yeah. Because different textbooks,
Yes, sir.
different methods, so that All are same, but they will follow the different approach. So, but we must know all the approaches. So this is all about when the light rays goes from rarer to denser, and as well as from denser to rarer. Do you understand, Ra? Now, at a time we will study in the same phenomena, same understanding, two mediums, when the light is entering from one time from rarer to denser, and again from that same refracted light ray is leaving from denser to rarer. So that is what we'll study, a case of light going from air into glass and again into air. This is the most important understanding in our this class 10th chapter, understanding reflection and refraction of light, rectangular glass slab. They will ask you to show the refraction of light through rectangular glass slab or parallel sided, understanding that one. So we have to draw this one. So here 2 times refraction will take place. So at a time we should represent both in the single diagram. So let us discuss. Shall we start now? Yes or no?
Yes, sir.
Yeah. All of you keep heading. The case
Yes,
of
sir.
light, the case of light, the case of light, the case of light, the case of light going from air into glass, the case of light going from air into glass, and again into air, and again into air. That is what our heading. Do you understand, Ra? Again into air. Is it okay, Ra? Yes or no?
Yes, sir.
Yes. So now, do you want again definite heading? The case of light going from air into glass and again into air. You keep heading important. Important you can keep aside. So all of you take your pencil and pen and draw the glass slab perfectly. Understanding. You can draw, understanding. Thickness is much bigger or lesser, doesn't matter. You have to draw. That's all. So you can take a big thickness, no, not an issue, or else a small thickness is also enough. So I am drawing the rectangular glass slab, so which is called as PQ. Understanding? PQ what? RS. Are you drawing? Along with me, you should draw. So nothing, Ray. We have drawn already 2 cases. Is it yes or no? All of you. Now we will merge the 2 cases.
Yes.
Nothing is there. We will just merge the 2 cases. Now I have taken a rectangular glass slab. PQRS. What is that? PQRS. Shall we start now? Shall we start? Now.
Yes.
Let us insert the, so as you know, first mention the mediums. First air into glass and again glass into air. Correct or not? So that where first, whatever you want from bottom top or up to bottom. I think up to bottom, top to bottom is easy for us. Is it yes or no? Yes?
Yes.
Yes, sir.
That is what you can prefer. So you can mention just, no need to rarer or denser everything. You just mention. First, this is what air. Is it yes or no? Air.
Yes.
Next, this is called as what? Glass. And this is called as what again? Air. Is it understanding, Ra? All of you?
Yes, sir.
Yes. So now, shall we go for it? Clear any doubt, you can ask me.
Yes, sir.
Now, with your own angle, insert the incident ray. With your own angle, insert the incident ray. Incident ray always, what is the name of the incident ray?
Oblique.
Understand?
AO.
Insert incident ray AO at point O. At point O. Obliquely. At point O, obliquely. Obliquely only will show the refractions. That is what I want. Remember. So mark some point O. Your choice. Whatever the point you want, you mark it. So I am marking a point which is, understanding here exactly. So this is my point I used to call it as O. So here I am inserting the incident ray which is called as what? What is it called? AO. Understand? So this is my incident ray called as AO. So now First itself, my suggestion I'm saying you, extend that line. This is the actual path. If it is the same medium, it needs to go in the same path. Is it yes or no, Ra? Yes or no? So now,
Yes,
all
sir.
of you from here, inside it is anyhow path will change. So kindly all of you, understanding, draw the line, extend that line till somewhat. I'm extending like this. Same way all of you should extend. For perfectly drawing this diagram, most important diagram, 90% children, again and again, they will do the same mistakes. So this is the, all of you should draw. All of you should draw like this. Have you remembered? Yes or no?
Yes.
Now, over. You have drawn it. Now, let us draw the normal. You should not draw the refracted light ray directly. You should draw what? Normal now. So let us draw the normal at point O. So imagine this is the normal. So incident ray is what? What is the incident ray? AO is the incident ray. Is it yes or no? So let us take the normal now. Normal answer should represent what? Dotted lines or solid line?
Daughter.
Dotted lines. That is what you should remember. So I am drawing the normal now at point O. At point O. So this is my normal. So let me imagine my normal is N and N dash. N O N dash. So this is my normal. So now what is the angle of incident? Can you able to say anybody? What is the angle of incident? This is called as angle of incident.
Yeah.
Is it or no? So this
AON.
is called as angle of incident. AON is the angle of incident. Do you understand? Yes or no?
Yes, sir.
All of you. And perfect draw. Whatever the diagram I am mentioning, everything you should draw. Understanding? And you have to follow this is all. So as we know that when it is entering from air to glass, increasing density or decreasing density? Rarer to denser or denser to rarer?
Rarer
To denser.
So what will happen? It will bend towards the normal or away from the normal? It will bend
Towards
When
the normal.
towards the normal. So you just, it will take place at where? Is it throughout the glass slab? Only at the point of incident? Only at the point O.
Point of
Yes or no? So whatever the bending
Yes.
will take place at the point O and till the glass slab next surface, it will travel with the same angle. Is it yes or no? Ra? Yes or no? So that is only called as what we should call refracted ray. What we should call refracted ray. You should remember this is only called as refracted ray. Refracted ray. And all of you note it down. This is called as refracted angle. What we should call? What we should call? Refracted angle. What is that? Angle between N and, understand, NOB. What is this? NOB. Do you understand? Do you understand or not?
Yes, sir.
Yeah, this is what the
Yes.
incident refracted ray. Now, it will reach us to the another surface. Again, this surface, let us imagine that surface is called as B point. This is only B. Is it yes or no? Ra? This is only B. Refracted ray OB. Now, again it is entering into the denser to rarer. Is it yes or no? Is it yes or no? So now, what we have to do? We draw the normal at this surface. Is it yes or no? Is it yes or no? We have to draw the
Yes.
normal at the surface. Now, this is what the normal I am going to draw. So this normal you can imagine M and M dash. What we should imagine?
M and M dash.
M and M dash. M and M dash. So now, if you are really smart and you tell me this refracted angle R and for this surface, this incident angle, for this surface incident angle, is it both are same or not? Is it both are same or not? This angle and this angle, both are same or not? That is what I am asking. Is it both are same or not? Whatever the angle present between normal and this refracted ray, and forget about this surface. This is the incident understanding ray for this surface. Now this angle and this angle is both are same or not? Observe carefully and
Yes,
tell.
sir.
Same or not? Always they are equal. Always opposite. Understanding. Remember, this angle and this angle is equal always. That is why I am representing with the two lines. Do you understanding? Two curved lines I am representing. Is it okay? Yes or no? Because we are inserting, this is what the same ray, correct? Whatever the angle will make here with a normal, same angle with this normal also. Is it yes or no? Nobody is saying confidently. So now, this is what the actual path of light. This is what the actual path of light. But what is happening? It is entering from denser to rarer. This is what the actual path of light. Understand? But it is entering from denser to rarer or rarer to denser? Denser to rarer or rarer to denser? Huh?
Denser.
Denser to rarer. So again, it bends away from the normal. But if you'll observe that refracted ray, which is coming from this medium, we should not say refracted. It is second time refraction, so that we can call it as emergent ray. What we should call? What we should call? Emergent ray. Remember, emergent ray. And that emergent ray is always parallel to the original path of incident ray. Do you understand, Ira? Original path of incident ray. You understand very well, yes or no? So this is what the emergent ray. So let us take this emergent ray is B. Understand? This is B. And this emergent ray is called as, understand, you can take A, B, oh, okay, you can take it as a C. So this is called as emergent ray. Now what is the emergent angle? Can you able to say? What is the emergent angle here? What is the emergent angle?
Second time refraction.
This is called as
EB and
angle. Is it yes or no? This is called as emergent angle.
Sir.
To represent with the E, with which to represent with what? Emergent angle. Understanding? Emergent ray. Emergent ray. So that the angle is called as emergent angle. So is it this angle and this angle is equal or not? That is what I want. Is it this angle and this angle is equal or not? All of you should say that. Always. You remember, angle of incident and the angle of emergence is always equal. Do you understand what I'm saying? So that is why
Okay, sir.
these light rays are understanding. This is actually the original path, but after refraction, it is changing the new path, but it is parallel to this original path. Is it yes or no? Is it yes or no? So that is the reason always angle of incident is angle of emergence. What you should remember here? Angle of incident is equal to
Equals angle of emergence.
angle of emergence. And you should remember, angle of refraction is always less than angle of incident or angle of emergence. Do you remember, all of you? So what I'm saying, always angle of incident, which is equals to angle of emergence, and it must be, understand, greater than angle of refraction. Is it understanding or not, all of you? This is what the statement. Or else you can write angle of incident is equals to angle of emergence. Understand? Which is less than, you can write angle of refraction is less than angle of incident or angle of emergence. Do you understand, Ra? Yes? Tell me. And few
Yes,
times.
sir.
I hope you understand this diagram very well. Is it yes or no? Like this perfectly how to draw in the exam also. No confusion at all. Here double lines. You can see I am showing the double lines here. And here I am showing single lines. Means this angle and this angle is equal. And this angle and this angle is equal. But you can see, actually if it is the same medium, the light ray needs to go like this. So the path is displaced. It is moved some away from that. Is it yes or no? It is moved away from it. Yes or no? New path it is going. So that is why this distance between this original imaginary path and the new path, so this path is only called as, let me imagine CD is that one. So that is only called as lateral displacement. What we should call, Ra? What we should call?
Lateral displacement.
All of you should remember. Lateral displacement. Lateral displacement. Lateral displacement. Is it understand? Yes or no?
Yes, sir.
Okay. So this is what we used to call as refraction of light through air into glass and again from glass into air. So now few diagrams, few times in exam also, board exam also, instead of incident angle, emergent angle, refracted angle, they will give in the form of theta 1. Theta is the angle representation, theta 1, and this is called as theta 2, and this is called as theta 3. Now can you say the relation between them? Anybody? Same way like this, can you able to say the relation? Theta 1, theta 2, theta 3. Either you can say exactly, say the relation. Let me see who will say. Please say the relation. I am asking yours only. Say the relation. Theta 1, theta 2, theta 3. How they are, which is equal, which is not equal, you should say. That is what I am asking. In the same way like this. What is this? You are all not kids, correct? Can I say?
Theta 1 is equal to theta 3.
Theta 1.
Sir, theta 1 is equal to theta 3.
Yeah. Theta 1 is equals to theta 3 and theta, understand, theta 3 is less than theta 1. Is it yes or no? Or theta 1 is equals to theta 3. Theta 3 is less than theta 1. Is it yes or no? Theta 2. Theta 2 is less than theta 3. Is it yes or no? Will you accept it?
Sir.
Yes, sir.
This is same thing I am writing, correct? Whatever here I have written, the same thing I have written. Just to note it down. Always refracted ray, refracted angle is less than these two angles, and the two angles are equal. Nothing is there. Do you understand it? Or else few cases they will reverse this. Theta 1 which is equals to theta 3. Understanding? And theta 1 is understanding. Now here correct, it is less than. Okay, here you can keep theta 1 is greater than theta 2. That's all. Or else theta 1 is equals to theta 3 and theta 3 is greater than theta 2. Both are same. Is it yes or no? Both the meaning is same. Yes? Nobody will answer. Is it the meaning is same or not? Just I am saying less than and less than, greater than. That's all. Nothing will change. But position is changing. So this is all about the refraction of light through air to glass and again glass to air. Draw this diagram and from below what is lateral displacement, what is emergent angle, and what is the factors to increase this emergent angle, means in the sense of bending of light, how we can increase. Even this glass slab also, suppose Pranav will take small thickness glass slab and understand Dileepan will take little bit more bigger, Arya will take little bit even more bigger. Then is it the refraction of light is same? Means all three different substances is glass only, but still the thickness is varies, so that what will happen, the bending of light will be more or less. So that is all we'll study in the next class, like factors which will affect the understanding refraction of light. That is all we'll study in the tomorrow's class. So but you have to draw this one and below note you keep and you mention this all the points. Is it okay, Ra? Because no textbook will give that point and we have to know that point. Okay?
Okay, sir.
Yeah.
You understand this one perfectly? Yalini?
Yes, sir.
Yes, sir.
If any doubt you can ask me. If not, you can leave from the meeting. That's all. Thank you. Kevin, you understand, Kevin?
Thank you, sir.